So Newman projections are just a way of showing 3D organic compounds as 2D. So there's two different types of Newman projections. There's the eclipsed version and then there's the staggered version. So staggered is more stable than eclipsed, okay? And the reason why is because, for example, let's take this as an example. Bromine has electron shells, multiple electron shells, right? And one electron is a negative charge. So both of these have negative charges surrounding them. So if we know that negative charges repel other negative charges. So for example, this one, right? We have bromine next to another bromine. Well, since we're forcing this bromine to be close to another bromine, the electrons are pushing against each other and they're really close to each other, right? So they're pushing away from each other and therefore it's making it unstable. Because this one, right, anti is the most stable because the bromines are the farthest apart. The electrons don't want to be next to each other because like repels like, right? So the bromine and bromine want to be as far away as possible from each other. And that's why this anti is the most stable. And that's when the biggest groups, in this case, it would be bromine, right? The bromines are the farthest away from each other. Now, if the bromine is to the left or to the right, we call that gauche. And gauche is just when it's not anti. Now, the eclipsed version, right? So this was staggered. All three of these were staggered. This is eclipsed. So even though it looks like the bromine is off to the right, what this truly means is that the bromine is directly behind the other bromine. So if you're looking at the structure, you wouldn't actually see the other elements because this bromine would be directly behind this bromine, this hydrogen would be directly behind it, and this hydrogen would be directly behind this hydrogen. So what that means is that this is a higher energy than these, right? Because here, even though the bromines are really close to each other, they still have some distance away. This one, since they're directly behind each other, that means that it's really high in energy. And that's why staggered, these three, are more stable than eclipsed. So if you ever have a question that's talking about stability, you would know right off the bat that eclipsed would have the highest energy, right? Because it's the most unstable. So this might be hard to see because, for example, they'll make you draw a Newman projection from a normal compound, right? So this would be the 3D version, and they want you to make a Newman projection. So the way to see it is, first of all, you can use your model kits, and those really help too. But the way I think about it is, if you just have a car, right? If you're looking at it this way, you have your side view mirror right here, right, with chlorine, and your side view mirror right here with a bromine. So now what a Newman projection really is just turning that entire car this way. If this was the front of the car, you turn the entire car this way, right, as if you were looking at it directly. And so therefore the bromine would be on the right and chlorine would be on the left. And then here we have a methyl group, so the methyl would go there. And then if you're looking like that, right, so this one's the methyl here is pointing up. And then as we see in the example, right, everything has to be 120 degrees. So the hydrogens would be here and here. Because remember, it's always implied, the hydrogens are always implied, because there's 2 hydrogens here, and then 3 hydrogens here, 3 hydrogens here. And so that's how Newman projections work. And so the main thing to take away is that eclipsed, right, eclipsed is really high in energy. So if you ever have a ranking question, eclipsed would be the highest energy, so it'd be the most unstable. And then if you only have staggered positions, anti would be the most stable, meaning the least amount of energy, right? It'd be at a lower energy level than the 2 gauches. So I hope that helped, and thanks for watching.